And we didn't do this one last class, did we?
No, we didn't do this class.
Okay. So we lost Indira. Indira is back.
Sorry.
No worries. We just have a couple minutes. Does anybody have any good news? Reba, you out there?
I'm here.
I got you marked in. And I just don't like this colder weather. I know it's not real cold yet, but it's cold enough for me. Lillian, you're there?
Yes, I'm here.
I got you. Did I miss anybody? Vanessa?
Did you get me?
Hold on, let me get Vanessa first. Cantulo. And who is this?
Ryan?
Ryan, let me check. Crouch. I have you now. Were you here last class, Ryan?
No, I had to go to work.
Okay.
So my husband has come.
Really?
The husband in Dubai.
Really?
And I'm at Houston now.
You're in Houston?
Mm-hmm.
Are you there for good now?
Uh-huh.
Wow. That's a big deal, Sharon.
I'm at my husband's place.
Yes, of course, I'd hope anyway. That's good.
Yeah, we stayed for a while in Austin too.
Wow, so you're all over the place maybe.
In almost all the
Emma.
yoga places.
Emma, are you here?
Yeah, I'm here.
I got you marked in. All right, so one more minute, we'll turn into a pumpkin and turn this stuff on. Well, Sharon, that's I'm happy for you that you get to be with your husband. I'm sure you're happy about that yourself.
I know, I'm too happy about it. His family is
You
also
are.
so nice.
Yes. Good for you.
Thank you.
All right, guys, we're going to start now. My clock says 7:60. No, it says 7:59 and 30. It's going to move over though. There it is, 8. And here we are. This is a problem that says writing the terms of an arithmetic sequence. It says write the first terms of the sequence in which A1 is 6. Again, the first term they give you counts. So that's your first term. You don't have to do another one. You don't have to do 7. You have to just do 6. And the first one they give you, then you put that into the equation. And here's how you read that. It's the number that you have from the previous one is then put into the equation. So if you look at A2, you put 6 minus 2 to give you 4. Then A3, you put 4 minus 2 to give you 2. Then 2 minus 2 gives you 0. And then 0, and so on. So that's an arithmetic sequence. It means you put the number that you have in for your answer from the previous problem into the solution. It's a pretty easy thing. Are any questions about number 1? Pretty straightforward. Are we good? Get it? Are you all hearing me anyway?
Yeah, I'm good.
Okay. Thank you for someone to answer. I appreciate it. Just lets me know that you can hear me. Now let's just use the formula for the general term of an arithmetic sequence, where you find the 8th term of the arithmetic sequence. Now, these are formulas. The formula is up in the yellow box. A to the 1 is the first term. N minus 1 is the formula times the difference. N is the term you're trying to find. So let's look at this, the solution here. You want to find the 8th term, and the first term is 4. So if you look under the solution, A1 is 4. Nth term is 8. 8 minus 1 is, of course, 7. And the common difference is negative 7. Now, I can share with you later on that there are ways to calculate that. And the difference is taking the second term and subtracting it from the first term. It will always give you the D. So if you take negative 3 and subtract 4, you get negative 7. Or you could take negative 10 minus 3, you get 7, negative 7. And all these, you'll get negative 7. Remember, you're subtracting them. So the arithmetic sequence in example 2, again, is pretty straightforward. You're just plugging it in. The hardest part for these is to know what they stand for. A1 is always the first term. N is the difference, N is the term you're trying to find. In this case, it was the 8th term. And D is the difference. Are we good on this one?
Yes.
Yes.
I appreciate the answer. Good, thank you. Now, number 3. Now, they want you to write the formula here. Well, to do that, you can see a negative 2 or 8 minus gives you a difference of 10. So 10 goes in there. The first term is negative 2. So the formula is in the third line, a negative 2 plus open parentheses n minus 1 times 10. Now, they expand it in the fourth line. They take 10 times n, which gives you 10n. Then they take 10 times 10, which gives you negative 10. They combine the negative 2 and the negative 10. They end up with 10n minus 12. This is, again, very simple, but it can be complicated if you try to do too many of these things in your brain at once. Remember, the D is the second term minus the first term. So that's 10. 8 minus 2. 8 minus a minus 2 is 10. The first term you can see is negative 2. Then they just multiply it out. 10 times n is 10n. 10 times negative 1 is negative 10. They combine the negative 10 and the negative 2, negative 12. Are we good in this one, everyone?
Yes.
Yes.
Appreciate that. Let's go to the next one. This is using an arithmetic sequence to model changes in the United States population. As you can see, there's some significant changes. You can see that in terms of white population, it's going down significantly by 20% almost. Latinos is going up almost double. African American is going up, and Asians are going up. So it says here, the data shows that in 2010, 64% of the population was white. You can see that. It says on average, this is to decrease by 0.45% per year. Write a formula based on that. Well, they give you the 0.45. The starting point is 64. So they take 64 minus 0.045 to get the first change, which is 6310. Excuse me, is 6355. And then they subtract it again and they get 6310. So in every year it's going down by 0.45%. So I mean, that's just common sense you see there. So the first term we have is 64. N minus 1, the difference is a negative 0.045. And they just multiply it out. You get a negative 0.045n. Negative times a negative gives you pot of 0.45. And there's your formula. Now let me ask a question to see if anybody's really paying attention. What does the N stand for? Does anybody know?
The sequence number.
If you look at the last sentence, it says the percentage of the United States population will be white.
So it should be the amount of years.
Exactly. It's the number of years. And if you calculate it, it will become eventually to 0% based on this model. All right. Now, in front of you is a formula. The formula is to find the sum of the first n terms of arithmetic sequence. And this is interesting. Not quite yet, but yet today it'll be interesting. So you can see if n over 2, a to the 1 is the first term, and a to the n is the terms you're trying to find. And that will give you the sum of the terms of that sequence. You can use the summation formula as well with your calculator. So here we're using this. We want to find the sum of the first 100 terms of the sequence that has 1, 3, 5, 7. They're odd numbers. Well, it says find the sum of 100 terms. So n is 100. The first term is clearly 1. And the nth term is 100. You can see 1 because it's the first one in the list. Now, if you plug these all into the formula, the total terms, if you look at the second line, a to the 1 is the first term. 100 is the total terms that you're going to add up. The formula said you subtract 1. And the difference between these is 2. 3 minus 1 is 2. 5 minus 3 is 2. So 2 times 99 is 198. Plus 1 gives you 199. So the sum of the first 100 terms of this sequence is that. Now, have we done number 6 yet? Have we done summation notation? I thought we had, haven't we? Maybe not.
Yeah, we did that last lesson.
Let's do this one for reinforcement again. Let's look what we have here. The summation notation says I, of course, we're going to use X. It starts at 1 and goes to 25. And you're going to plug each number in and find and have it add up. So according to this, the summation of all those numbers is 1400. Let's go to our calculator. It's really the easiest way to do it anyway. So we're going to do summation notation. I think it's under math. And it should be number 10. You could go backwards and get there sooner, but there's summation notation right there. You all see that? It's number 10 under math.
Yes.
Yes.
So I'm going to hit this, enter, and it's going to give me all these little boxes. Now, A is the variable. We're going to use X. And it's going to start at 1. We're going to push it to the right with our calculator. It moves it up at the top to 25. So we know we're going to use numbers 1 through 25. Now, it's blinking where we put the expression. The expression was 5i, which means 5x. So we're going to put in 5x. And then I think it said minus 9. And then push it out. We'll hit enter. And you see you get the answer. It's really very easy. Pretty cool. Everybody understand where I went to get this under math?
Yes.
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 Okay, good. And you see we got the same answer as they did. Now, this is a real world problem. A grandmother has saved up $500,000 for her golden years. She wants to move maybe into an adult residential community for a 6-year period beginning in 2018. The model given is below. And she says she wants to know if she'll have enough money. Well, look how this thing is designed. The model says the first year is multiplied by 1. You add the 64,130, and you get 65,930. And you keep doing it because the next year is going to be 65,930. Well, 18. It doesn't show you doing the others in between. But let's look at this. So use the formula correctly. You have the first amount of 65,930. It tells you the sixth amount, if we put in the 6, is 74,930. Using the formula, which you see right in front of you, 8 to the 1 is 65,930. 8 to the n, that's the 6 years, 74,930. 6 over 2 is 3. You add those two numbers in between. The total amount that she'll have to pay for 6 years is $422,580. And so 500,000 will be enough, and she'll have a little bit left over. But that's expensive. I didn't mean to go too fast. Is there any questions of anyone? Man, that's a 15-minute lesson. You guys good?
Yeah, I'm good.
I have no reason to hold you any longer then. I'll say hasta la vista till next class, Monday.
I
Let me-
showed up. I wasn't
wait a
here for
second.
roll call.
Yeah, I got to do roll yet. I'm sorry, Amanda, you're right. Amanda, let's see. I got you. Let me just mark down the folks who I don't have so you guys can tell. So Nikki Anderson, are you Next page. Lexa. Marissa Flores. No Marissa? Alma Garcia. Go down further. Everybody here there. Edith Narrow. Did I get you? Yeah, I got you. You're there. I see you. And I marked you down. Joshua Trejo. Are you? No, Joshua? My fishing buddy. Holly, are you here?
I'm here.
I got you then. And that's everybody. Everybody here, I can see. I've got you all in. Stay warm. I'll say hasta la vista. Any
Good night.
questions of me?
Have a good night. Thank you.
Good night. Sorry it went a little fast, but I hope it was good. Goodbye.
Good night.
Good night.
Good night.
Thank you.